Welcome to part 3 of our webinar series, Teamcenter Integration Across Enterprise Systems. In part 1, we explored our digital enterprise vision and overall integration strategy. Part 2, we talked a little bit about planning and some fundamentals of OpenPDM. In this one, we're going to talk about OpenPDM and a technical deep dive after we show some integration demos to kind of go over an overview and give you an idea of the types of integrations possible with OpenPDM. And then in the next part, we'll discuss integration success stories and how to get engaged. We'll start by showcasing a few different demos that include integrations from different systems into Teamcenter. So we're going to start with Teamwork Cloud, where you might have model-based systems engineering data, including requirements data, and you use that as an authoritative source of truth. And you want to replicate those requirements in the Teamcenter to allow traceability and connectivity to design data or other data that you might have available within your Teamcenter PLM. In the second demo, we'll take a look at Teamcenter and CodeBeamer Federation. CodeBeamer is an ALM system, and in this case, Teamcenter uses a PLM system. So you want to create bug issues and link requirements between those two. In the third demo, we'll look at Windchill and Teamcenter integration, where you might use Windchill as a repository for your Creo design data, and then you want to be able to synchronize that to Teamcenter, maybe through a release process or another process, in order to use Teamcenter as a PLM system, and then use that data downstream, for other applications as well. With our first demo, Teamwork Cloud Replication, we'll start by triggering the process that then creates a OpenPDM process instance within the process server. We'll export data from Teamwork Cloud, map that data into a Teamcenter format, and then import that data into Teamcenter. We start within Cameo Systems Modeler and then connect to Teamwork Cloud. We've got data that's centered around a Mars rover. This is a JPL-powered open source, Raspberry Pi Mars rover data. But we've created a lot of different data within different systems in order to kind of showcase that integration. And within Cameo Systems Modeler, we've created some requirements that are focused on the Mars rover and the power, locomotion, structure, controllability, feedback, and other things like that. These are structured requirements, but we have a lot of flexibility with how we're mapping data, and we know that not everyone uses requirements the same way within Cameo Systems Modeler. So we log into Teamcenter, and within Teamcenter, we can show that the data has not been created yet. So we're going to go ahead and query for the data, and then just see that the data has just been created as part of this process that was run. And later on, we can go through and show that the data with the same query, shows up within the system. So we go back to OpenPDM. We're going to start the process from within OpenPDM. This is just kind of a default triggering mechanism in order to create that process instance. We choose the process that's going to be created, and then watch the process run within the OpenPDM process server. Since there's not a lot of data involved and no file exports or anything, it's pretty quick. This process is created and then runs through an export, a mapping, and an import. And you can see the durations for all those. You can click into that and see the before and after for any mapping inputs. You can visualize that. So in this case, we're taking a look at what might have been imported into Teamcenter. This is after the mapping. And you see that we've created these requirement revisions. And then relationships, so kind of a hierarchy, a parent-child relationship between those different requirements within Teamcenter. So now we go back, we run the same search after we've created the data, and you can see that we've imported the data. So we can also take a look at the top level requirement and then kind of explore the structure of what those requirements are as well. So we'll search for that 357 requirement and then open that up and take a look at the structure. In our second demo, we'll integrate Teamcenter with CodeBeamer. You see CodeBeamer on the left is an OSLC consumer, so it can use the OSLC standard, and PROSTEP offers an OSLC provider adapter that can then enable any of our connectors to be OSLC compliant providers. So we'll integrate Teamcenter with CodeBeamer utilizing this OSLC bridge. In this demo, we're going to showcase two use cases. First, creating a bug report from Teamcenter into CodeBeamer ALM, and then second, linking requirements from CodeBeamer into Teamcenter. This is going to be done with OSLC that utilizes a URI, a link, in order to kind of create that digital thread through links between systems, and then can utilize that link in order to pull data on demand to keep the latest data up to date within both of the systems. So within this, first we right-click on the assembly and then create that bug report, and then you'll see within CodeBeamer that the bug report has been created, and you can click on it and then update it within CodeBeamer. And then those updates that are made within CodeBeamer are going to be federated and live queried between CodeBeamer and Teamcenter in order to show that up-to-date information within an OSLC preview window. So you see that there's been a tracker ID with that URI that's been created, and then you can select that and then show the preview of the data through OSLC, including all the properties. This is the latest information that's available from within CodeBeamer. It's federated into Teamcenter so that you can use it there. And then within our second demo, we're going to go ahead and create a link and trace requirement via OSLC. So OSLC enables you to query a system in order to find data and then relate it. So we'll use our OSLC query from PROSTEP, search for requirements within CodeBeamer, and then be able to link that data to the assembly that we've selected here. So we go ahead and find and select the test requirement and then say add to item revision. That'll create that URI within Teamcenter, and then you can trace that as well from Teamcenter to CodeBeamer and see the results of what that is and the properties within the window below, giving your users that information. In our third demo, we're going to showcase synchronizing native Creo data into IPEM integration for Teamcenter from the Windchill source system. So we'll start by triggering the process from a manual trigger within Windchill. That's going to start a background process within OpenPDM in order to export the data from Windchill, map the data into Teamcenter formats, and then import that data into Teamcenter. So we'll start our demo from within Windchill, and we'll show off the assembly that we're going to synchronize. Could be that you have designers using Creo in Windchill, or it's a legacy system that you want to keep around after you're introducing Teamcenter for other purposes, maybe as a general product lifecycle management or manufacturing analysis, or for any other reason, really. And then you can synchronize data between the two systems to keep them up to date, and the designers can still use Windchill. This can be started as a manual trigger here, but it makes a lot of sense in order to automate that process and use like a lifecycle status or a workflow in order to have a synchronization at a regular interval that makes sense to your business process to keep things up to date without a manual need to synchronize it. So you see this process has been started within the OpenPDM process cockpit. It's exporting the data from Windchill with JLink, importing the data into Teamcenter with our IPEM controller, as well as using the Windchill and Teamcenter connectors for exporting and importing the product structure, attributes, other documents, and other data as well. So with that all completed, you see it took about 3 minutes and 46 seconds. Because of the CAD export, it takes a little bit of time and import as well. We'll go ahead and open that up within IPEM and then show the assembly within Teamcenter and IPEM. It's been created, and you can open it up and use it, as well as generate JT and use the other data that's associated with the designs and product structure within Teamcenter. Now that we've explored some demos of OpenPDM, we can kind of dig into some of the platform architecture. So within the demos, you saw a lot of the components that are overall within this architecture. There are the different connectors to systems like Teamcenter, Windchill, 3DX, and other systems available on the lower left. You have the orchestration layer in the middle. That's that process server that you're deploying the process and then creating instances of that. And those are started with the triggers that are in the upper left. You could do monitoring. And then there are different services like mapping service or also the translation services, notification services, and other services that are kind of baked into the BPM and workflow engine as well. There are quite a few different connectors available for OpenPDM, and they've been supported for a long time. So you see here with 3DX, going back to Matrix 1 and Innovia V6, with Windchill, with legacy info engine and APIs, and then REST and the method services, and now modern Windchill Plus. Same thing with SAP, supporting back with R3, R4, and now new modern cloud OData interfaces. Same as with Teamcenter, so been supporting Teamcenter, for a long time, almost since the Iman days, with legacy Teamcenter engineering as well. OpenPDM is a set of microservices. These can be deployed on Kubernetes or OpenShift or other solutions, and makes it rapidly deployable, highly available, and then supporting modern architectures and deployment methodologies, as well as cloud-based solutions. We showcased in the demo some manual triggers, but really best practice is to have automated triggers with OpenPDM. But there's a variety of different trigger types that we could utilize. Manual, like embedded within PLM systems or user interface, or within the OpenPDM process server, like we showed in some of the demos. Really, workflows are the best way to do it, though, and that could be triggered by an event within a system or a workflow process within the system, so that it listens for status or lifecycle changes. We can also do time-based synchronization, so see what the delta is, over a amount of time, and then synchronize just what the changes are. And then also message queue or watched folder type of implementations. And really all of it's driven by this REST message service that's supporting workflows and manual or time-based integrations as well. OpenPDM has a real robust administrative interface, allowing you to configure the product as well as maintain it. So you can see status and instances and review all the details of all the processes. With that, we conclude the third part in our 4-part integration series for Teamcenter. Thanks everybody for joining, and remember, PROSTEP's here to help, so reach out.